Student, now you are going to learn a new topic known as electric potential at any point due to an electric dipole. For understanding this, we required a dipole. A dipole is an equal and opposite charges separated by very small distance. So we required an equal and opposite charges separated by very small distance. Let minus q and plus q. This is the equal and opposite charges separated by a small distance. Let the distance is 2a. From the center O, this is A. So this will also A. The sum of A plus A is 2A. Now let us take any point and let this is any point. Join this point to the center. Now A, B. Let this be C. Join the point C to A and C to B. This angle are same. This is theta, vertical opposite angle. Let us draw a perpendicular from here. This is M. Draw a perpendicular from here. This is N. P is the dipole moment. P equals to Q into 2A. Direction from negative to positive side. So it is written dipole moment is here. In right triangle BOM cos theta is equals to base by hypotenuse. So OM is the base, so it will be OM and hypotenuse is OB. OB is hypotenuse, OM is the base, OM, and OB is the hypotenuse. So OM. What is OB? OB is A. Put here A. So you have OM is equals to A cos theta. Since triangle BOM is congruent to triangle AON, because these are vertical opposite. This OA and BO is same A and 90 degree is there. So by RHS both are congruent. So therefore ON, this is ON is equals to OM and which is equals to, therefore you can write ON equals to OM which is equals to A cos theta. Now what is the potential at C due to charge at A? This is VA. Potential at C due to charge at A is VA. So VA is equals to K minus Q divided by AC. This is equals to minus KQ. AC is equals to NC and this is minus KQ. NC is equals to NO plus OC. Let OC is R. So you have this is equals to NO plus OC. So this is minus KQ upon R. This is NO. NO is equals to A cos theta and OC is R. This is said to be VA, potential at C due to charge at A. Similarly, we have to find potential at C due to charge at B. So it is VB is equals to KQ upon BC, which can be written as KQ. BC is equals to here CM. So this is VB is equals to KQ and CM means CO plus CO minus OM. This is equals to KQ, CO is R and OM is A cos theta. So you have a potential at C due to charge at A and charge at B. Their sum is said to be total potential at C. So total potential at C is total potential at C is V, which is equals to VA plus VB. Put the value of VA, which is minus KQ upon R plus A cos theta plus KQ R minus A cos theta. These are the two values. We have to solve it, simplify it. For simplification, take the LCM. So this is R square minus A square cos square theta. Here KQ is outside common. So we have minus R minus A cos theta plus R plus A cos theta. So minus R cos R and plus R will cancel out. And this minus multiply with this minus become plus. So A cos and A cos add up. So it will be 2A cos theta. So you have KQ into 2A cos theta upon R square minus A square cos square theta. We know that P equals to Q into 2A. So you have V is equals to KP cos theta upon R square minus A square cos square theta. Since A is very small, so A square term is neglected. So if you neglect A square cos square theta, then you get V is equals to KP cos theta upon R square. This is said to be potential at any point due to an electric dipole. Now if you want to represent this potential in vector form, then you have to do some step. V is equals to KP cos theta divided by R square. Right here R and right here R. Multiply numerator and denominator of RHS by R. So you have K P dot R upon R cube. This is said to be vector form, in position vector form. If you want it in unit vector form, then further you have to write V equals to KP dot R cap into R vector divided by R cube. Cancel this, it is R square. So V equals to KP dot R cap divided by R square. This is in the term of unit vector. This is in the term of position vector. Here unit vector A cap is equals to A vector upon A magnitude, which can be written as A vector by A. So here, so this means that A vector is equals to A cap into A magnitude. So here this is R vector equals to R cap into R magnitude. Thus you have seen that electric potential at any point due to an electric dipole's expression in scalar form and in vector form. Now there are two cases. One is electric potential on the axial line. Case 1, electric potential on the axial line or end on position. Here you have the minus q charge, here you have plus q charge. This is a dipole. This is the line C. This is the angle theta. You have to move this C slowly move this C and fall on the line AB. When C will overlap on B, then angle theta becomes 0 degree and it is said to be axial line or end on position. This means that theta equal to 0 degree. So V axial is equals to Kp cos 0 degree divided by R square. This is equals to Kp upon R square because cos 0 degree is equals to 1. So this is equals to V axial. Memorize the formulas. Now next you have to find case number 2, that is on the equatorial line. Electric potential on the equatorial line. Next you have to find on the equatorial line. On the equatorial line or bisector of dipole or broad side on position. Here you have to move this C point from this angle slowly and it become perpendicular on AB. You have to make perpendicular on AB. So here theta is equals to 90 degree, or therefore V equatorial is equals to Kp cos 90 degree upon R square, which is equals to 0 because cos 90 degree is 0, because cos 90 degree is equals to 0. Thus you have learned electric potential at any point due to an electric dipole. Let us see a numerical based on theory which we have learned till now. For that, here I am taking a dipole. This is a minus q charge, this is plus q charge. Dipole moment P is equals to 4 into 10 to the power minus 9 coulomb meter. This is origin O, this will be A and this is B. The question is, we have to take an equal axial point here. This is C. Let the distance from O to C is R, which is equals to 0.3 meter. Then in this situation, what will be the value of electric potential? So the answer is V axial is equals to Kp upon R square, and the value of K is 9 into 10 to the power 9. P is given, this is 4 into 10 to the power minus 9, and R is 0.3 centimeter. 0.3 centimeter. You have to convert 0.3, let it be in meter, no problem. If it meter, I have written meter and take it meter. So R is 0.3 meter. So write here 0.3 square. So you have 9 into 4 because 10 power 9, 10 power minus 9 will cancel and become 1. So 9 into 4 is here and denominator side 0.3 into 0.3. Move this point 10, move this point, this is 10, 3, cancel this 3, we have 3. So it is 400 volt. So it is 400 volt. Now the second part, if I take a line here and this line, it is D. OD is again R. OD is again R and R is same 0.3 meter. Then what will be the value of potential here? So this is equatorial point. This is equatorial point and we know that V equatorial is equals to 0 in any situation. So the potential here is 0. Now I am giving another situation. Suppose we take a line like this. This is R, this point is E and this angle is 60 degree. This is again 0.3 meter. Then what will be the electric potential at 60 degree angle with the dipole? In this situation, number C part, V is equals to Kp cos 60 degree divided by R square. You know that Kp by R square is V axial. So this is equals to V axial into cos 60 degree. V axial is 400 volt, we know that. and cos 60 degree is half. So we have 200 volt. Thus, you have learned electric potential at any point due to an electric dipole, and you have seen the numerical based on this. I know that you are understanding physics very well from my video lectures. So, do like, subscribe and share my channel. Thank you.